All right, welcome everyone. Okay, we are going to pick up from where we left off. We are looking at absolute value equations and inequalities. So let's go ahead and start with equations. As you see, we've kind of started on it a little bit already, and we've worked on it already some in class. So let's just go ahead and fill this in. So give me just a moment. Okay, so what you're looking at here, it's the absolute value of a number. So I'm just going to fill these in. Okay, I don't like how that looks, so let's erase that. And let's make it a little, nope, let's undo. We're going to do here, make it a little thinner. Okay, there. So the absolute value of a number, there you go, is its distance from 0 on the number line, okay? And the absolute value of a number is always positive. This you already knew. Okay, so if you were to look at a number line here, I'm just going to draw this in real quick, and here is 0, and you look at -5 and +5. The distance from 0 to 5 is 5. The distance from 0 to -5 is also 5. That's why we can tell you the absolute value of 5 is 5 and the absolute value of -5 is 5. And it's always a positive number because distance is always positive. So let's go ahead and move on. And so we got a few little problems that we want to do absolute value on. And so what you're going to do is you're going to substitute in and then simplify it. So if you have absolute value of -6b and b is 1. So you're going to have absolute value of -6 times 1. Whoops, there you go. So the absolute value of -6, and that happens to be +6. Okay. Here we're going to substitute in again. So absolute value of 4 times -2 plus 7. So absolute value of -8 plus 7. Absolute value of -1, and we know that answer is also 1. Okay, so pretty straightforward. Here we have 5 plus the absolute value of 3 times 3 minus 4. So 5 plus the absolute value of 9 minus 4. 5 plus the absolute value of 5. Well, the absolute value of 5 is 5. So 5 plus 5, the answer is 10. I realize I have a lot of steps in here. You put in as many or as little as you need. I just put in a lot so that students can follow me. Okay, and moving on down. Now what we're going to do here is you're going to see the same problem, but we're going to make slight changes. And so you're going to see how to solve it. What you're going for, the goal here, is to get the absolute value by itself so that then you can do some work to it. So for the first one, when you do absolute value, keep in mind we talked about you can take the absolute value of two numbers, a positive and a negative equivalent. So when we do these, we have to work them as though x could be positive or negative. So we're going to do x minus 12 is equal to 32, and then you do x minus 12 is equal to -32. Okay, so when you do that, you're going to add 12 here, add 12 here. So x equals 44, and then here we're going to add 12 and add 12. But here x equals -20. And so you should be getting two answers every time. On number 2, what you're seeing is, what you want to do is you get the absolute value by itself again, so we're going to divide both sides by 2. When you do that, you get the absolute value of x minus 12 equals 16. And then again, x minus 2 equals 16, and then x minus 2 equals -16. So that x is 18, and then x is -14. Okay? Here, you want to add the 4 before you do that. So again, the same type of thing, but we're going to add 4 to both sides. So you're going to get the absolute value of x minus 12 equals 36, and then you're going to do x minus 12 equals 36, x minus 12 equals -36. And then you can finish that. Here, we're going to follow order of operations, so we're going to add 4. Notice the goal is still to get the absolute value by itself. So you're going to have 2 times the absolute value of x minus 12 equals 36. Then you're going to divide both sides by 2 so that the absolute value of x minus 12 is equal to, what is that, half of 36? Oh my God, 18. I know I just went like stupid for a second. So then you're going to have x minus 12 equals 18. And you also need to solve x minus 12 equals -18. And that's how that works. So you notice we just went through and the whole goal is always to get the absolute value by itself. So we used order of operation to do that. And you will always get two answers. So the next part here is let's talk about a no solution, empty set. You'll see that, or you'll see this symbol. I always do it like that so you actually see it. So now here are the ones where you get no solution. Absolute value of absolute value is equal to a negative number. Never going to happen. Absolute value here equal to a negative number. Never going to happen. Let's subtract 5 here. So you have the absolute value of x minus 9 equals negative 5. Again, never going to happen. When you get to a point where its absolute value equals a negative number and there's nothing else on the left side but the absolute value, you're done. It's an empty set. Never going to happen. So here, let's do this. So checking for extraneous solutions, that's the ones where mathematically you can solve them, but when you think about them in the real world, they don't really make sense. Okay, so here you're going to have the absolute value of, let's not do absolute value. Let's do, okay, we're going to do x plus 6 equals 3x minus 2, and then x plus 6 equals negative 3x minus 2. Notice one positive, one negative. Here, let's see, if you subtract your 6 equals 2x minus 2, and then 2x equals 8, so x equals 4. Okay? So if you plugged 4 back in, you would get 10, but if you plug 4 here, you get 12, so that works. Now here you're going to have x plus 6 equals negative 3x plus 2. Add that, you're going to get 4x plus 6 equals 2. Subtract, you're going to get 4x equals negative 4, so x equals negative 1. So if you do negative 1 here, you're going to get 5. And if you do negative 1 here, you're going to get what? Negative 5. So positive 5, absolute 5 is not going to be equal to a negative. That's one where this one works, this one does not. So does not work. Okay, and what I did is I replaced the x here, and I got positive 5 equals negative 5, which is not going to be true. Here, when I replace it, I get 10 equals, that's 12. I got 10. So 10 equals 10 works. Okay, so let's go on to inequalities, and we'll go to the next one. And so now you want to be able to graph an absolute value inequality, write one, and then solve one. Okay, so pretty good. So let's go ahead. I'm going to pause for just a minute. Alrighty, so what we're looking at here is this is the next part that we want to get to is now we want to graph absolute value inequalities, write them, and solve them. Now, the way the book is worded is they have you work through all of it and then they kind of sum it up. I'm just going to share with you what I want you to write. So if I were you, I would be copying down this piece right here so that you know what that looks like. So what you need to know, though, is that if you have absolute value of a number absolute value of x equals a number. Notice that your graph is just 2 dots, okay? That's pretty easy, okay? If you have absolute value of less than or equal to, that's an and problem, okay? And if you have absolute value is greater than or equal to, or greater than or equal to, that's an or problem, okay? So again, please feel free to pause this wherever you need it, but that's what you need to know. If it's equal, it's just the 2 dots. If it's less than or equal to, it's an and. If it's greater than or equal to, it's an or, okay? So let's go back to our notes, and we're going to see that. And you see that's the first thing we start off with, okay? And so what you want to do here is when you graph, you want to graph that as an and problem, and we've actually already talked about that. So let's do red though, because that might show up better on here. So we're going to have a negative 4 and we're going to have a positive 4. These are both open circles, and since this is an and, it's everything in between. Now, here we're going to have negative 4 and positive 4. This is an or problem because it's greater than, which means we want a is greater than 4, so here you go. And we want a is less than negative 4, so here you go. Okay, and that's what you need to pay attention to, whether or not it's an and or an or. Okay, that's how you graph them. Now, the next piece you need to do is you need to be able to write them, okay? And so what you want to do is you want to write all numbers greater than or equal to 5 or less than or equal to 5, okay? So we want to write that as an inequality. And let's knock that piece out. And then we'll be all done. And you guys will have done a great, great job, okay? And so I'm just making sure that I'm showing you what you need to know. Okay. Okay. So how would you write that? So you're writing an absolute value inequality. Okay, keep in mind that's an or, so I'm going to go and show you that just a little bit, okay? So you want greater than or equal to 5 or less than or equal to negative 5. So how we're going to write that, remember or is greater than. So we want the absolute value. Whoops, don't want that. I want the absolute value of x is greater than 5. Okay, and then remember how we're going to have negative 5 and positive 5 and, oh, greater than or equal to. Sorry, we need that. So this is going to go that way, and this one's going to go that way. Now we want an and. So remember, and is absolute value is less than or equal to. So absolute value of x is less than 7, okay, because there's no equal to. And so if we want an and, we want a negative 7, and we want a positive 7. And remember what that graph looks like? That's an open circle. Okay, and we're looking for everything in between. So there you go. And then the last piece is we want to be able to solve multi-step absolute values. Okay, so let's do that. And then, like I said, we're all done, guys. We are all done. So this one's going to be, we're going to do the same thing like we always do, rewrite it as a compound inequality. So 3x minus 12 is greater than or equal to 6, and 3x minus 12 is less than or equal to negative 6. Okay? Perfect. Now let's do that. So we have 3x is greater than or equal to, if you add 12, that's 18. X is greater than or equal to 6. Here, we're going to have 3x is less than or equal to, if you add 12, you get positive 6. So then x is less than or equal to 2. So let's do 2 and let's do 6. Now what we got to remember, it's greater than or equal to, which means it's an or problem, okay? And you don't need to do that because see, x is greater than or equal to 6, closed circle going that way. X is less than or equal to 2, closed circle going that way. So I didn't really need to look up at the notes, okay? Now here, let's do the same thing, only now we know our inequality starts off a little bit different. So we have 3x minus 12 is less than or equal to 6, and then 3x minus, minus 12 is greater than or equal to negative 6. So if you add 12, you're going to get 3x is less than or equal to 18. So x is what? Less than or equal to 6. And in here, if you add, you get 3x is greater than or equal to 6. So x is greater than or equal to 2. So 2, 6. X is greater than or equal to 2 is closed going this way. And x is less than or equal to 6 is closed going this way. So it's an and. So what you're looking for, and we'll do a different color, is you're looking for this here and this here. Okay? That's how you solve a multi-step absolute value inequality. Okay? Guys, that's pretty much it. I'll be glad to answer questions, but that takes care of the end of our notes. So I thank you, and I'll see you on the next video.